Hello and good afternoon, everybody. Thank you for once again tuning in for our monthly Citizen Science webinar series. First of all, I want to thank the folks with the library for helping us keep these series going each month. We're very excited for today's session. We have Brendan Turley joining us today. Brendan is an assistant scientist at the Cooperative Institute of Marine and Atmospheric Studies at the University of Miami's Rosenstiel School of Marine and Atmospheric Sciences. His work is primarily engaged with the understanding of water quality issues and how they relate to harmful algal blooms and its effects on important fish populations. One of the projects he is working on is a collaborative water quality monitoring program with commercial fishers in Southwest Florida. Today, he's going to be sharing some of his experiences with other community and citizen science-based projects. And with that, I'm going to turn it over to Brendan.
Thanks, Rebecca. I really appreciate the introduction and the opportunity to talk today. So, like Rebecca said, I do have experience working with commercial fishermen in a collaborative sense in a cooperative monitoring program. And so I'm not going to talk about that, which could be a whole nother seminar, which I think would be interesting to talk about. But what I am going to talk about today is some volunteer work that I've been doing with the AGU, so the American Geophysical Union Thriving Earth Exchange. And I'll explain a little bit about what that is if people are not familiar with it. I'm going to talk about this work that's a collaboration amongst various people up in La Crosse, Wisconsin. They did primarily all the work, and I just served as kind of like a project manager slash matchmaker, so to speak. So right off the bat, I like to do my acknowledgements, and I want to thank all these amazing people that made this work possible. So SPACE, which is the primary group that I work with, the Safer Playspaces and Community Environment in La Crosse. Jamie and Kathy were amazing. Researchers at the University of Wisconsin-La Crosse, Chris and his student undergrad volunteers who did most of, if not all, the science that you'll see. So they did amazing work, and I want to highlight all the good stuff that they did. And then the Thriving Earth Exchange folks on the back end, Maria, Blank, and Liz. Maria and Blake, who I think have moved on, but Liz is still there, I believe, doing the comms work. So thanks to all of them. Like I said, they did most of the work. I'm just here presenting what they've done and kind of how I fit into all this. So the first part I want to talk about is what is a Thriving Earth Exchange? I think it's relevant to understand what it is if you're not familiar, to give you some understanding of how I got involved with the people in La Crosse, Wisconsin in the first place. So the Thriving Earth Exchange is part of the American Geophysical Union, and it supports community science by helping communities find resources, project managers, and experts to address pressing concerns. So they really work to make connections between people that have needs, like people in the communities around the world, primarily in the United States. And this map shows the blue dots where the projects are located, and there might be some missing. And so primarily in the continental United States, but there's some in Central America, Mexico, Caribbean, and some across the world, kind of sparsely populated. If you want to learn more, there's the website down below, thrivingearthexchange.org, or go to AGU, or just search AGU Thriving Earth Exchange. They're pretty easy to find. So how they do what they do is they put out these calls for community leads. And this encourages communities of any type, including environmental justice, local governments, faith communities, etc., to submit some sort of idea, priority, or project that they want to work on that addresses natural hazards, environmental health, pollution, usually some sort of intersection of community and earth science. The program is free to communities to apply. There's no cost at all. It's completely voluntary and free to anybody, which is amazing. They actually provide a little bit of funding support. Like we got about $1,000 to do some work that I'll talk about later. And they just ask that you have some sort of priority issue and some project idea that's science-based. So that's one part of it. The second part of it is what they have. They have what's called a Community Science Fellowship. And that's how I plug into this. And what that is folks can apply to these fellowships. And what you do is you basically work as a project manager to try and connect the community leaders and some sort of science expert to help them solve or achieve some sort of objective. So projects typically last about 12 to 18 months. And there's a minimum requirement of having 3 years experience in a science-related field and needing an undergrad degree. And all career levels are eligible. So you could be a recent undergrad up to a retiree, which is amazing. There's a 2-day intensive training online, and you learn about various skills like active listening, project design, cultural humility, strategic communication, and so on. And one of the nice things about this in this day and age is it's completely remote. So you could apply to be a fellow and work with folks probably anywhere in the world, considering that the range of where these projects are located are growing. And this little circle wheel on the right-hand side is their scope, match, solve, share paradigm. And I'll kind of step through my project to kind of show you what that means. So moving on to part 2, an idea is born. So the idea or issue that was at the heart of the project that I was involved with is recycled rubber mulch. So tires are pretty ubiquitous anywhere that there's cars, right? And tires are usually restricted from landfills to reduce mosquito breeding habitats and put the potential for tire fires, which are hard to put out. So to find some way to recycle them or reuse them, old tires are recommended as playground fill, or they're labeled as safe because it was safer to fall onto rubber than, say, the ground, supposedly. But the health and environmental concerns are not well known. So, for example, because these materials, these tires, have a whole suite of chemicals in them that were used to produce them, there's volatile organic compounds, there's heavy metals. They can also contribute to heat island effect and organic compounds such as PAHs, phthalates. And I bolded one compound, the 6-PPD, because it's come up a lot recently in news and literature. There's actually, and don't quote me because I forgot, I was going to add it, but I did not. I apologize. But I do recommend you look up 6-PPD if you're interested, and salmon, because they found that there are some pretty strong linkages to tire dust that has this chemical compound leaching into streams and causing salmon and trout deaths. So it's not just that it's causing some potential environmental harm. It's pretty closely linked to unusual mortality events to very important commercial species. So the environmental effects are real, and so there's an obvious concern of how these might be affecting, other unintended consequences, or places that these are being used, the unintended consequences of that. So the parents of the Crosse took notice, and you can see the picture on the top right. These child's hands are just covered in black dust from playing on one of these playgrounds. So parents observed debris and stains on the children's skin and clothes after playing on these playgrounds. And this quote is quite amazing. I had to put it in. My daughter recently had surgery, and much to everyone's surprise, they found a piece of rubber chip in her ear. It had gotten in there a few weeks prior, and I had hoped that it worked its way up, but it hadn't. And I'm thankful they found it and were able to remove it. So on top of these obviously noticeable effects to children, these playgrounds also turn into heat islands. So in the summertime, the surfaces temperatures can reach in excess of 147 degrees Fahrenheit, which can cause burns. And they're noticeably warmer than natural play spaces like wood mulch or grass. There's also the potential for environmental spillover effects. So this picture on the bottom right hand, you see that the mulch has spilled out over. So a lot of times these playgrounds are built with some sort of like barrier underneath that to protect and potentially keep that there. But if they spill over, it's unknown what happens to those chemicals. And that's something that we had wanted to kind of potentially follow up on, but proved difficult and or really expensive. So, but regardless, everything that we've learned so far suggests that there's not just a health effect, there's probably an environmental effect, just like I talked about the salmon earlier. So considering all this, the parents decided they wanted to investigate the safety of these materials. And that leads us to Space Lacrosse community leaders. And these are the two individuals that were the community leads that submitted their project idea to the Thriving Earth Exchange. Jamie O'Neill, she's an experienced community leader and a tireless advocate. She really thinks passionately about these things and is continuing to work on this project and this idea, and actually wants to, I think, ultimately have like a consulting or some sort of firm that will help convert these spaces into more natural spaces. Kathy Van Muren, she would appreciate me using a leaf, because every time we had a Zoom call, she would have a leaf or some sort of like environmental picture instead of her photo. And she's a retired ed resident, and she's been a tireless advocate also over a lifetime for various environmental and community-centered issues. So these two amazing individuals were my community leads that I worked with to develop this project further. So part 3, a partnership is formed. If you remember back to me talking about the Thriving Earth Exchange, there's the scope in part of the wheel. So this all started back in May 2022. I met with Jamie and Kathy, and we just had a discussion about what their interests were and what led them to seek out help from the Thriving Earth Exchange. We just discussed various things, and really centered on the issue with rubber chips and astroturf, which we didn't follow up on, but was also a concern at the time in school facilities and playgrounds. So before we ever had this conversation, they had built up this coalition of parents who had identified this issue, like I mentioned previously. And they had already enlisted the help of, I believe, as a grad student, might have been an undergrad, and I apologize. They completed a literature review and drafted this nice letter that had all the different known chemicals that are present in these materials, and sent it to the city council, public school district, the board public school district, and the city parks and rec. Basically telling them, we know about these things and these materials. We should at least consider what this means for the health of our children and people in general who use these spaces. So in addition to this, we also talked about expectations for a project, and they identified that building community, having a lasting effect at preventing repeated mistakes. They really wanted to have a scientific basis for the impacts of the children. So when we first started talking, I asked them specifically, is the end result that you want all the recycled materials, the tires and AstroTurf replaced in the community spaces around you? And they said, not necessarily. We want to know what the science says. We want to know, are these spaces, are these materials safe? Or if there are like toxic or potentially toxic chemicals in there, at what level are they? And is there some sort of guideline that we can use to determine whether there's like a threshold at which we say we want to have them removed? And they also wish to have some sort of decision support tool to use in the future. So in the course of our conversation, we kind of identified various aspects of safety of the safety of these materials could be attributed to. So the health effects, like the particles and chemicals that could potentially be not only have some sort of dermal contact that would get in through their skin, which is a concern, obviously, but then also potentially ingested. I mean, I have a child, she put things in her mouth all the time. It just happens, whether on purpose or not. There's also the environmental effects that I've already talked about. So are these chemicals, as the rainwater washes over them, are they then leaching into the soil and potentially contaminating the groundwater? And then something that was really quite interesting that we really wanted to, we wanted to tackle it all, obviously, because it's a really interesting and concerning issue. We wanted to look at the radiated heat as a combined effect. So not only do you have these heat islands that can cause burning, but also can lead to heat strokes. The heat can also lead to volatile organic compound release, which can then be inhaled and cause other issues like dizziness and falls. So there's these combined effects that, taken together, really calls into question the safety of these materials being used for children's play spaces and being labeled as safe. So the potential goals that we identified early on was collecting data on the effects of these playgrounds, doing a literature review, which they'd kind of done, but since it seems, 2 years since it seems like the literature has kind of exploded, reviewing the studies on the health and environmental impacts of these materials. And then potentially also inventorying the playgrounds for materials used and the age of the materials in their community. And during the course of our project, we did most of that, quite honestly, because we had to kind of achieve the goals that we had set out. So we talked about a lot in these first stages about what the issue was that they thought was most pressing and how best I could help them achieve some sort of goal. And at this point, we left it kind of broad and open for a reason. And that's because we wanted to match or find a partner scientist. And that's the next part of the Thriving Earth Exchange wheel. So we did scope. We tried to identify what the problem was and kind of broadly define how we might approach it. And now we wanted to find some sort of science or technical expert that could help us achieve some goal. So we kept the goals broad so we wouldn't limit what type of scientists we might enlist the help with. And scientist here is pretty broadly defined. It doesn't necessarily have to be someone with an advanced degree, but someone who has some technical or expert knowledge in some sort of field. That's kind of how we've loosely defined it. But early in our conversations, we ID'd that we wanted some sort of chemist to help us understand what chemicals are in these materials and at what levels they were found. So part of the Thriving Earth Exchange programming, we developed a help wanted advertisement with expectations for who we wanted and a short project description. And this is advertised on the AGU Thriving Earth Exchange website. And we preferred a local or regional partner and also someone that we could get students involved with. So we focused our efforts on local universities. And we found someone quite quickly. So remember I said we started this conversation in May 2022. Jamie cold called a bunch of her local contacts. And in August 2022, she found Chris Rothhaus at University of La Crosse. So in the same city that they are located. And he was identified as a potentially good candidate, came as a recommendation of Jamie's contacts, because he had specialties in environmental and analytical chemistry with the focus on heavy metals. And he also had previous experience with community science. He had developed a protocol with some other folks at, I believe, the parks and, either the park system, the National Park System, or USGS. But regardless, he was identified and we interviewed him and it was a match. I mean, he was very much aligned in personality, which I think is very important as a working relationship, but also his interest in it too, because he also had community science experience to begin with. So we had our team more or less put together, and together we moved forward. However, we had to decide how we're going to move forward. And this is the next part of the Thriving Earth Exchange wheel. So we did our scope. We kind of identified what we're trying to do. We matched ourselves with the technical expert, Chris, and now we're at the solve portion of the wheel. So over several meetings, we discussed how to test the rubber chips, because that's what we ID'd as the most reasonable course of action for potential, I'm going to label toxic chemicals, because we had known at this point, having looked at the literature and seeing that there was a lot to be concerned about. And the other factors that I talked about didn't seem as easy to address. And that's why we had picked a chemist like Chris. So there was some conversation back and forth whether we wanted to test for organics, which I had previously talked about as being potentially very bad, versus heavy metals. So organics, Jamie and Kathy really want to test for organics, but Chris's background was in heavy metals, particularly in mercury. So taking that together, the literature at that point seemed pretty sparse on some of the specifics we were looking at. And so it's kind of identified that any new information would be a positive outcome. And a bonus point for this, Chris already had some undergrad students in mind to help out with this project, Katie, Will, and Abigail. And this was all in September of 2022. So just to kind of backtrack and keep you thinking about how this all is unfolding in time, remember I talked about how these projects are typically 12 months to 18 months in length, and they can last as short as 6 months. It kind of depends upon, the project and the people involved. And Thriving Earth Exchange keeps it very open-ended and non-prescriptive, because they understand that context matters a lot depending upon where you're at, who you're working with, and what the problem is you're trying to address. So with all that in mind, we were working in Wisconsin, and winter playground activities are quite limited. So this was fall when we were discussing this. we made a decision that what would happen is we would develop some sort of science protocol in the fall and winter, and the scientists, primarily the students, would do some sampling and develop the protocol and refine it in the winter time. So when the spring thaw came around and kids are then actually going to be exposed to these materials again, we could then hit it in earnest and do some sampling. And I've highlighted here the student-driven activities because they really were the backbone driving the sample collection and the protocol development and refinement over the fall and winter. They did an amazing job. And all that, I don't know if you guys are familiar with Wisconsin or cold weather areas in general, but you don't really do much playing on playgrounds and you're not really exposed to the ground. You do a lot more sledding. So I'm going to briefly describe the science protocol, and if you're really interested to learn more, there's more materials later, but the students put together these fantastic videos on how to do it, because in the midst of all this, we were trying to keep in mind also having some sort of community-driven or community engagement beyond just the students, like having community members actually go out and sample. So they really try to keep that in mind when developing a sampling protocol. But generally, the protocol was to collect the rubber chips from playground and try to get like high use, low use areas. So either like near a slide versus like off to the side, surface and at depth. And the students tried various combinations thereof to kind of optimize the protocol. Next, the chips would then be soaked in acid, and they tried various chemicals and pHs. They picked hydrochloric acid because it mimics stomach acid. We also talked about trying to develop a saliva analog. And I think that would be just like water that was adjusted to pH. But ultimately, just decided to do deionized water. And they tried various temperatures, so like room temperature versus a temperature that's closer to body temperature, and also different lengths of time for digestion, and found that there was a trade-off and there wasn't much gained after 24 hours, really. So 24 hours was decided upon as the digestion time. That water was there, the extract was then run on what's called an inductively coupled plasma mass spectrometer. And I am not a chemist, although I do have a minor in chemistry. This machine can tell you what's in there. I'll just leave it at that. So initially, they looked at arsenic, chromium, cadmium, magnesium, lead, and zinc. After various trial and error, some of these materials never got above level of detection, so limits of detection. And so the protocol was then optimized for a couple of key materials. Ooh, I misspelled lead. Lead's supposed to be PB, not PD. So it was ultimately optimized for magnesium, lead, and zinc. One, because they're easily discriminated by the machine, and two, because there is some health concerns associated with these, especially lead. When you talk about lead in children and people, you get people's ears. The next step, as we came out of the wintertime, was trying to get the community involved. And we ID'd Earth Fair, which coincided with Earth Day and La Crosse, as a potential way to get the community engaged. So what we did was we made a poster of the initial results, and the students, well, I say we, but the students did most of this. And if you want to see the poster, it's there on the QR code. Students put together this poster with initial results from the optimization and running some of the samples from some places around the city. And then put together a bunch of sampling kits that people could then go out and take samples and then return back to the lab to have analyzed. It was cold and rainy and windy, but it's Wisconsin in April. I think the kids handled it pretty well. They handed out more than 30 kits, but many more people were very interested that just didn't take a sampling bag. About 2/3 of the bags were returned, and the samples returned were a mixture of rubber chips, pour in place, wood chips, artificial turf, and sand. something I hadn't mentioned so far is that when they were doing their the protocol optimization, they did rubber chips, but they also did wood chips as a contrast. So if we're trying to say that rubber chips are bad, it's good to have a control. So they tried to find wood chips that were already in playgrounds, already seasoned. That was another consideration. You get like a material that's brand new, or you get one that's seasoned, and that's also part of the idea behind getting things at the surface versus depth, because they're seasoned differently, whether due to wind or rain or sunlight. And so there's a various different materials that people returned. And these samples are also supplemented by the students for analysis. And the analysis was completed over the summer and fall of 2023. So if you remember back, and when I first started talking about all this, we started in May of 2022. So we're just over a year into the project, and we're really starting to get going. And I had some initial, I wouldn't say concerns, but I was keeping mindful of our time frame. And we all kind of decided it wasn't really that much of an issue. One, because the winter time we knew we couldn't get much done being in Wisconsin, and the summertime really was when we thought most of this was going to take place anyway, to get the community involved at least. So that's the basics of what we did, and now I'm going to talk about how we then presented and really tried to get the word out about what we found and why it mattered. I've kind of talked about this, but this is going to go in a little bit more depth. So the results from the community sampling, there's elevated lead. So the plots on the right-hand side, lead is on the top. The acid concentration, you see that red bar that sticks up, that's a rubber chip. It's much higher than anything else for lead. There's some increased amounts of zinc, and in the rubber chip particularly. And manganese, interestingly, the wood was higher than the rubber chip, which is kind of hard to see on this plot. And copper was also kind of elevated. And we really relied upon Chris to help us interpret this. He's our technical expert. Zinc, magnesium, and copper, they're not so much toxic. It's more that it's more of a taste sort of issue. But obviously, lead is an issue. Any amount of lead is bad, and there is EPA guidelines. So that's something that we had to discuss. Is one, how do we present these results that are meaningful, which comes down to like sample standardization, whether you make it by volume or by weight. But they did it in parts per billion. But also, how do you reference this beyond just rubber to wood, which is one way to do it and pretty effective. But we tried to find some sort of reference. And the only thing we could think of, because there's not really much about this, was EPA drinking water guidelines, because we're kind of assuming that these materials are going to end up in the mouth. We talked about dermal abrasion and dermal contact, but it was just outside the scope of what we had accomplished with the time and money involved. The other levels weren't really detected or at a level concerned. And I will mention this work continues, and the students have the eventual goal of getting a peer-reviewed publication. So more power to them, and I hope that they achieve that goal. We set out on a huge, not huge, but a consistent communication strategy. So I talked about the Earth Fair booth previously. There's the Space Lacrosse blog that Kathy and Jamie had been putting on, and still continues this day. There's been some lapses recently, just because there's not much going on. But usually about once a month they put out something. Since we have been working on this project, there was 4 presentations and counting, not including this one. So Jamie gave a presentation at the Fall AGU conference, which is a huge conference if you've never been. Chris gave a lacrosse Rotary Club talk in December 2023, so a local Rotary Club. 2 of the students gave a talk at the 27th annual meeting of the Midwest Society of Environmental and Toxicology and Chemistry. And they won runner-up place, and they also received funds to present at the national meeting in this month, so October, in Fort Worth. So I actually, putting this together, realized I should reach back out to them and see when it is and how they did. And then also coming up in spring of 2025, the students were going to present this at a student research symposium. Jamie is pretty good about putting together press releases. She's very adept at that. And she also put out a letter to the editor in June of 2023 to raise awareness during the heat wave. I'm not sure if there's a heat wave everywhere, but 2023, the summer of 2023 was incredibly warm, especially in Wisconsin. And we took that opportunity to highlight the dangers of these materials on play spaces. And there's also a mini initiative that Jamie and Kathy took on that I didn't really have much to do with, where they were getting their community involved in a heat gun initiative. So they would, their local community libraries had heat guns, like the infrared thermometers, that they could check out and then go and measure the temperature to see what the temperature is. I wish I had results to present for that, because that's something we talked about as a potential project, but I do not. And throughout the whole time, there's been this extensive media coverage. So the University of Wisconsin-La Crosse News picked it up. You can see here, there was plenty of local news coverage on local channels for the various events that occurred. And I'm going to talk a little bit more about this, a little bit of foreshadowing, but there's more to come to talk about. And there's extensive coverage for things that they accomplished. And we also got a regional nonprofit news outlet, the Wisconsin Examiner, to produce an article, and that's up there in the top right-hand side. So we got lots of media exposure and coverage that I think elevated this issue to not just like a boutique issue, but something that everyone should be concerned about, especially if you have a child. So part 6, all's well that ends better. Some of the things that we accomplished. So there were 2 playgrounds that got transformed in August 2023. So remember, we started in May of 2022. Crowley Park Emerson School. So it's a park that shares a space with a school. They got resurfaced to have natural wood chips. And then in August 2023, Northside and Cooley, which share a building, Northside's a public school, Cooley's a Montessori, they also had their rubber chips taken out and resurfaced with natural wood chips. On top of that, so all this kind of overshadowing or umbrellaing this, or however you want to put this, is that the City of La Crosse, Parks and Rec, the City Council, and the school district were all engaged by Jamie and Kathy to resurface as much as possible. However, as you can imagine, funding's limited. And Jamie did a lot of work to get apply for a grant, but however, it was not funded. So the unfortunate reality is that these efforts are kind of put on hold until there's more money involved. But the positive is that the city is engaged and is willing to do it. They just don't have the money to, do it willy-nilly. And in other news, Katie, which was one of our undergrad, she has graduated during the middle of this. I guess it was spring of 2023. So before all this, she graduated and got a job with an environmental consulting firm testing for heavy metals. So I'm not saying we influenced her because she was already in it, but I think the experience probably helped her understand like what it is she likes to do and the opportunities that may be involved. So best wishes to Katie. So let's put it all together. One of the final products that we produced in our project, says it's at this point, my end of it is completed, is we put together what's known as a community action toolkit. And it was developed by the team, but Jamie was the primary motivator and workhorse that did this. She did an amazing job. She created this cover photo, which I swiped for my intro slide, and she did an amazing job. I mean, we helped her and kind of guided her in what we thought was good, but this is all her. She did an amazing job. She has got some good graphical skills. So it's part community guide to help communities understand the process that we took, but it's also part narrative because we thought that was important to help not just have this guide that's a how-to manual, but to show how we also did it, to put things into context, because sometimes things can be abstract until it's put into like a particular context. But there was a balance there because we didn't want it to be, a 100-page tome that no one reads. I believe the page number is around 30 pages. It's quite digestible. If you want to take a look at it, There's a QR code. It's free to download. Please use it, share it, use it. We developed a communication strategy with the AGU Thriving Earth Exchange Commons person, Liz Crocker, and we pegged June of 2024, so that's going on 2 years since we started, to release, which coincided with both the Get Outdoors and Get Together Day and also National Safety Month. And it was to emphasize the importance of safe and healthy public spaces. So it's really a culmination of everything we did. It has the research that was done before I got involved. It has the sampling protocol. It has stuff about Thriving Earth Exchange. It has some of the initial results. Not all the results are there. If we want to do that, we could update it. It really is a nice resource that puts together what you could do if this is an issue that was of concern to you. And something we also talked about is, do we make this guide just for removing recycled tire materials from playgrounds, or do we make it more broad? And ultimately, we decided to keep it somewhat narrow, just because at some point it would have. I think we were afraid of it losing coherence if we got too broad. Because one of the arguments I made in this discussion was, well, if you're thinking about it, what we're doing is we're taking a space that we want to use for something that we think health is important for, and we want to assess it to see what the safety is or what's there, right? So realistically, if one was to be thinking a little bit more broadly, this sort of process could be used for other things such as community gardens, for example. Say you have, a plot of land that used to be a building or a house or whatever, and you want to make a community garden. Maybe you want to know what's there and you want to test it. And so you kind of have to go about and be thorough and methodical about how you do that. And so it could be used in that context too. And I'm sure there's other uses that could also be used for it in addition. So I'm going to wrap up here. This is my last slide. What can you do? There's kind of two things to think about. If you're worried about recycled materials in your community spaces, you can start talking to your community. You can go on Facebook. I don't exactly recommend that necessarily, but if that's your thing, go for it. You can also talk to your PTA about the play spaces at school. Talk to your neighbors. Talk to people at parks. You can also download our kit, our toolkit. It's free. There's the QR code again. And if you just want to learn more about this project to maybe get ideas of how it came about and kind of the evolution of it, I recommend going to the spacelacrosseblogspot.com just to kind of understand, more about this project. The other thing is, if you want to get involved with AGU Thriving Earth Exchange, there's actually 3 different ways, 4 depending on how you count, that you can get involved. One, if you have a project, if you're a community lead, you can propose a project, and the next cohort is supposed to be opening up mid-2025, so it's coming up. If you were interested in being a community science fellow like me, which I highly recommend. It was an incredibly productive, amazing experience. I wish I could do it again, but they don't take repeats. The next cohort's to be determined, and it's determined by the community lead cohort. So they follow in sequence. So whenever they get their community lead projects figured out, then they'll announce the next community science fellow cohort. And also, there's many projects that need expertise from technical experts. Currently, I was just on the website before this, there are 25 projects that need experts, or you can just send them your name as a potential to add to their list of potential experts. They range from environmental health to GIS to community safety. There's a whole host of things. A lot of it has to do with climate change and flooding. There's some really interesting projects there. So if this is anything that even remotely interests you and you have some spare time and or looking to get more involved in some community projects, not necessarily where you're at, but remotely, I highly recommend you go to their website. It's super easy, thrivingearthexchange.org, or just look up AGU Thriving Earth Exchange. It'll come right up. Their website is not very big. It's super user-friendly. You can find exactly what you're looking for. And if you have any questions or want to talk to me more about this project or even what I do more, because I've done community science in my real, I was going to say my real job, but my day job We talk about that too. And with that, I'm done. I'm happy to take any questions, and I really appreciate the time you guys have given me to talk about what I've done.
This is Cassandra again from NOAA Library. Thank you so much, Brendan, for that presentation. That was a really incredible project to hear about. We do have time to answer audience questions, so please type them in the Q&A chat. It's located on the right side of your screen. There'll be a little tab labeled Q&A, and you can enter your questions in there. Remember, your first name will show up on the screen with your question, but you can also ask questions anonymously if you choose so. And then I had a question just to get us started on it. When you were broaching this project with your community and like with the city, was there any sort of pushback that you faced from people or other groups?
No, I wasn't so much in interfacing with the community, but Jamie and Kathy were very much integrated in the community. And talking to them, it seems like people were very much on board with what they're saying. I think because, most people have goodness and good intentions involved, especially when it comes to children, and it's hard to say, oh, well, let's just keep things the way they are, especially when we know there's a potential harm.
All right. Well, if no one has any questions, then like Brendan said, you can reach out to him at his email address. And that concludes the Q&A portion of our seminar. Do you have any last comments, Rebecca?
Yeah. Once again, I want to thank everybody for taking the time out of their day to hop in and participate in this webinar. It is a monthly series, so we do have our next one is coming up on November 14th at 3 p.m. Eastern Time. John McLaughlin from the Department of Education, NOAA Department of Education, will be coming in to analyze the data that NOAA collected from NOAA projects in the most recent report to Congress for the implementation of federal prize and citizen science authority, as well as discuss the efforts in our agency to support and grow participatory science. And also, if anybody is interested in a particular topic that you would like to see covered in our webinar series in 2025, or if you would like to present on a project or a topic like Brendan did today, feel free to reach out to us at citizenscience@noaa.gov.
Awesome. Thank you so much. We hope to see everyone at our next seminar. Thank you for attending and have a great rest of the day.